Today we are going to discuss about the chapter name Linear Programming. Introduction. Linear programming is a method for finding the optimal values, maximum or minimum, optimization we call, of quantities subject to the constraints when relationship is expressed as linear equations or inequalities. There are some terminologies related to the LPP. Term objective function. Its definition is the linear function which is to be maximized or minimized under given constraints. Constraints definition. The restrictions, linear inequalities, or equations in which variables of an LPP which describe the conditions under which the optimization is to be accomplished. Non-negativity constraints. The assumption that negativity values of variables are not possible in the solution. So they are described as x greater than or equal to 0, y greater than or equal to 0. Feasible solution. The set of points whose coordinates satisfy the constraints and non-negativity of a linear programming problem is said to be the feasible solution. Infeasible solution. A solution of LPP is an infeasible solution if it does not satisfy the non-negativity restrictions. Optimal feasible solution. A feasible solution of LPP which maximizes or minimizes the objective function is called its optimal solution. Optimal value of objective function. The optimal value, maximum or minimum, of the objective function is obtained at a vertex of the feasible region if it is bounded. If there is more than one point, that means vertex, where the objective function is optimum, maximum or minimum, then every point on the line segment joining any two such vertices optimizes the objective function. Feasible region. The common region determined by all the constraints including non-negativity constraints of LPP is called feasible region or solution region. Feasible region is also a convex set. Feasible region may be bounded or unbounded. Infeasible region. The region other than feasible region is called infeasible region of the LPP. Next, corner point of a feasible region. A point in the feasible region which is the intersection of the boundary lines is called corner point. Infinite number of optimal solutions. The LPP may have more than one solution because of the nature of the objective function. Each of such optimal solutions is referred to alternative optimal solution. Hence, there can be infinite number of optimal solutions. Different types of LPP. Term diet problems. Definition. In diet problems, amount of different kinds of nutrients constitutes which are to be included in a diet are determined so as to minimize the cost of the desired diet such that it contains a certain minimum amount of nutrient are constituted. Manufacturing problems. In these problems, we determine the number of units of different production which should be produced and sold by a firm when each product requires a fixed manpower, mission hours, labor hour per unit of product, warehouse spare per unit, output, etc. in order to make maximum profit. Transportation. In such type of problems, a transportation schedule as to be find the cheapest way to transporting the product from plants, factories situated at different location to different markets is to be determined so as to minimize the cost of transportation subject to limitations, constraints of demand of each market and supply from each plant or factory. Investment problems. Investment portfolio from a variety of stocks or bonds is established that will maximize companies' return on investments. Advertising firm problems. Effectiveness of advertising activities in the field like TV, radio, newspapers is maximized by allocation of limited advertising budget. Formation of a LPP. The three steps in the mathematical formation of an LPP are as follows. Number 1. To identify the objective function as a linear combination of variables. Variables are x and y. And to construct all constraints, that is linear equations and inequations involving these variables. Thus, an LPP can be stated mathematically as maximize or minimize z equal to ax plus by subject to the constraints aix plus biy less than or equal to or greater than or equal to ci, where I runs from 1 to n, x is greater than or 0, y greater than or 0, non-negative constraints. Number 2. To find the solutions, feasible region of these equations and inequations by some mathematical method. Number 3. To find the optimal solution is to select particular values of the variables x and y that give the desired value, maximum or minimum of the objective function. Some important theorems of LPP. Theorem 1. Let R be the feasible region, convex polygon of a linear programming problem, and let z equal to ax plus by be the objective function. When z has an optimal value, maximum or minimum, where the variables x and y are subject to constraints described by the linear inequalities, this optimal value must occur at a corner point, vertex of the feasible region. Theorem 2. Let R be the feasible region of a linear programming problem, and let z equal to ax plus by be the objective function. If R is bounded, the objective function z has both a maximum and a minimum value on R, and each of these occurs at a corner point, vertex of R. Method to solve linear programming problem. Corner point method. Number 1. Find the feasible region of the linear programming problem and determine its corner point, vertices. Number 2. Evaluate the objective function z equal to ax plus by at each corner point. Let capital M and small m be respectively denotes the largest and smallest values at these points. When the feasible region is bounded, capital M and small m are the maximum and minimum values of z. Case 4. Fourth point. In case the feasible region is unbounded, then number 1. M is the maximum value. Z if open half plane determined by ax plus by is strictly greater than M, has no point in common with the feasible region. Otherwise, Z has no maximum value. B. If M is the minimum value of Z, small m, if open half plane determined ax plus by is strictly less than small m, has no point in common with the feasible region. Otherwise, Z has no minimum value. Note, if two corner points of feasible region are both optimal solution of the same type, that is both produce the maximum or minimum, then any points is also an optimal solution of the same type.